So here we are given m processes, and each process has a maximum need which is less than n. So we first draw the m processes starting from P0. It will be up to Pm, and now each process has a maximum need of n. So we don't know what is the value of n, and it is always less than, or it can be equal to n, it can be less than n. So we are taking it as arbitrary value, any arbitrary value, as n0, n1, n2 dot 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 up to nm, which is the maximum need of each process. Now in order to have a deadlock, we need to hold back one resource from every process. So we are holding back one resource from each of these processes. Now the question is given that the sum of the needs is less than m plus n. So we will try to prove this point in order to get our answer. If the sum of their needs is not less than m plus n, then there will be a deadlock in the system. So we add these values. And also we add a plus 1 here to remove the deadlock. This is hence this becomes the minimum number of resources that are required to avoid the deadlock in the system. Now our maximum resource available is n. So the value of n should be either be equal to this or it should be greater than this. So this is the final equation we are getting. Now the value of 1 here is repeated m times, so we will write this as n0 plus n1 plus n2 plus dot 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 up to nm, and this value of 1 is repeated m times, so we will write it as m into 1. This is less than equal to n. Now this is known as the sum, which is given sum of all their needs. So this is the sum of all their needs. So we will replace this by capital N, representing the sum of all their needs, which is less than, here said that it is less than n plus n. So here it is coming n minus m plus 1 is less than equal to n, and n plus 1 is less than equal to m plus n. Yeah, if we move this m here, and hence we are getting this equation. But this is not, these two are not equal. Because why it is not equal? Because we are having still plus 1 here. If we remove that plus 1, this equal to sign vanishes, and this becomes n is less than m plus n. So we get our initial condition which is given in the question, and hence this system is deadlock free. Thank you.